introduce what we're going to be talking about next. So our lab activity, and hopefully you've done the reading before, because this is going to give you a little heads up with answering some of the questions that you're going to have to do as we go along here. So our first question is, we want to measure the force of friction. What exactly could we use to measure the force of friction with? What devices have we already talked about? Okay, hopefully you remembered that the two devices we have talked about are spring scales, because they have a spring on them. So if you pull on the spring scale, it's got a scale, and it measures how much force is being applied to the spring scale. And then we also have modeled and demonstrated something called a force sensor. So force sensors and spring scales are used for measuring forces. So the force sensor is more accurate because it's digital, but it also has a little bit more robustness in that it can measure pushes as well as pulls. So I can pull on the force sensor and it measures that pull force, or I can even push on the force sensor and it measures that force as well. So we are going to use force sensors to measure forces. All right, in our friction lab, you will get a friction board, and a friction board has 4 different surface roughnesses that are on this friction board. So based on your reading, there was a constant that was mentioned in the reading that describes just exactly how rough a surface is. So what is that constant called? Okay, that constant is called the coefficient of friction, and it looks like this. Let me get a erase it here. I know, I'm doing the best I can. So it looks like that. It's a Greek letter mu. So it's pronounced mu, mu. So if you're familiar with Pokemon, that's the pronunciation of it. It's kind of like a scripty looking U. And we use mu sub k to stand for kinetic friction, the coefficient of kinetic friction. Ooh. And then if I wanted to talk about the coefficient of static friction, where it just starts to slide, that would be mu sub s. So that is what characterizes the surface roughness. And that's the focus of our lab. We are going to graphically determine the coefficient of static friction and the coefficient of kinetic friction. Now, we are going to keep the surface constant, so we're just going to pick one type of surface to do our lab experiment on. So we're going to have our friction block here, and we're going to use the felt side, and it's going to go downward on top of our friction surface. We're going to attach to it a force sensor. So this force sensor is going to measure the tension in the string. But what I really want to measure is the friction. So let's just start with something simple like kinetic friction. So if I want to measure the kinetic friction, what do I need to make sure that I do correctly when I'm actually running the experiment so that this force sensor, which is measuring the tension in the string, is equivalent to the kinetic frictional force? So hopefully we've realized that as long as I pull it horizontally, so I need to keep this string perfectly horizontal when I'm pulling it, and I also need to pull it, stuff's out of the way here. I need to keep it perfectly horizontal, and I need to pull it with a constant speed, and we kind of eyeball that constant speed thing. I just want to pull it at a constant speed. So if this is in equilibrium, then this tension force is going to be exactly equal to that frictional force. So that part is part of the introduction to your lab, is explaining that principle of equilibrium and how we can use this force sensor to make an indirect measurement of friction. Because I don't have a friction meter over here. I have this force sensor that can measure the tension. So we're going to use that piece. All right, so we've got kind of the first half of it here. So hopefully from our reading, we know that the force of friction, and I'm just going to have a generic frictional force here, is going to be equal to mu, and then this is the part that we want to change. We want to change that and create an experiment where we do something with our lab activity here, and as a result, do something to the force of friction so that we can graphically determine that coefficient. So the next question is, what could I change about this so that I can get different values of friction that I can measure with my force sensor? So oftentimes students will say, I just need to change the mass of this, and I'm just going to put another mass on that. And you would be sort of correct. So if we look a little bit more deeply about friction, we're going to just do a little live action experiment here. So take your hands and put them together, and then just rub them gently together. And you can feel the force of friction between the palms of your hands. Now, press your hands closer together. Press them together hard, and then do the same thing. Slide your hands across from each other, and you can feel that that force of friction has actually gotten greater. You have not changed the mass of your hands. That part hasn't changed, right? but what you have done is pressed your hands together more. So we're putting kind of those surface little irregularities, we're pressing them in even more. I always like to use this little example again of explaining what friction's all about. So hopefully these are familiar to if you've ever had a pedicure done. They're used between your toes to separate your toes out a little bit to paint them. But these are clean. These are not for my toes. If we look microscopically at a surface, so even though the surface looks really smooth, it actually has a lot of bumps and grooves in it. So when two surfaces are pressed together, those little bumps and grooves kind of settle into each other and they get kind of hard to pull. So that's kind of what static friction is. I'm trying to pull it, but all those little bumps and grooves are trapped in each other. And when you finally pull it with enough force, well, then it starts riding on the top of these bumps and grooves, and that's where we start seeing kinetic friction. But if I press them together even more, I'm pressing these in all together like that. I press them together even more. It gets even harder to slide. And when they are sliding, they're kind of grabbing each other and it's really tough. So that's surface roughness and why that friction matters. So pressing them together is what's going to affect it. So what's happening here, when I add more mass, I'm actually pressing down and pressing these surfaces together. Because if I look at where friction occurs, it's that interaction between the surface and the object itself. And it's that normal force, which is really a measure of how much those surfaces are being pressed together. So when we change the normal force, that will change the frictional force. So my next question is, what do I have to do about the lab? I'll kind of get to that question. If I need to measure the normal force, which is how much the surface is pushing up on my device, as long as I keep everything perfectly squared up, my free body diagram, then that normal force will be exactly equal to the weight. So in a sense, when you said change the mass, you were kind of right, but we really needed to connect it to the actual physics. It's the normal force. So I measure the weight. As long as everything's all squared up, again, I've made an indirect measurement of the normal force because I can measure the mass, and then multiply it times 9.8 to get the weight. And as long as I am in equilibrium and it's not accelerating up or down and all my forces are perpendicular to each other, then that normal force is equal to the weight. And that is kind of the underlying idea of what we're going to do for this lab. So when we look at our equation for friction, here it is, the force of friction is equal to mu, and this is whether it's static or kinetic, times the normal force. So if this is our independent variable, the one that we can change because we can add masses pretty easily, and then friction is what we measure, then we can create a graph, and then guess what this is going to represent on our graph. So just think about that one. Next time we get together, I'll take you through how to use Logger Pro to make these measurements and what the graphs are actually going to look like. All right, so be well, and I will see you soon.